This video is made by Kevin Biju, 19pmc337 of Marian College Kutikana, Autonomous, as part of the assignment of Artificial Intelligence course from Marian College Kutikana, Autonomous. The contents are about the classical models for an artificial neuron. Artificial neuron. An artificial neuron is a connection point in an artificial neural network. Artificial neural networks, like the human body's biological neural network, have a layered architecture, and each network node has the capability to process input and forward the output to other nodes in the network. In both artificial and biological architectures, the nodes are called the neurons and the connections are categorized by synaptic weights, which represent the significance of the connection. As new data is received and processed, the synaptic weights change, and this is how the learning occurs. Artificial neurons are modeled after the hierarchical arrangement of neurons in biological sensory systems. In the visual system, for an example, light input passes through neurons in successive layers of the retina before being passed to neurons in the thalamus of the brain and then onto the neurons in the brain's visual cortex. As the neurons pass signals through an increasing number of layers, the brain progressively extracts more information until it is confident it can identify what the person is saying. In artificial intelligence, this fine-tuning process is known as deep learning. The network of perceptrons. Perceptron is a single-layered neural network, and a multi-layered perceptron is called the neural networks. Perceptron is a linear classifier. Also, it is used in supervised learning. This helps to classify the given input of data. This is a simple image of a perceptron functioning. Architecture of perceptron. Here we have a constant value. We are giving inputs to that, weights onto it, and a weighted sum, and towards the step function, and at last to the output. Working of perceptrons. The perceptron works on these simple steps. All the inputs x are multiplied with their weights w. Let it called k. Yeah, x1.w1 up to x5.w5. That's dot indicates into multiplication. Add all the multiplied values and call them weighted sum. Here this is an example of this weighted sum. Sigma 5k where k equal to 1. Term we end with, and the sigma signifies the sigma for summation, k the formula for the nth term, and k equal to 1. The k is the index and 1 is the term we start with. Apply that weighted sum to the correct activation function. Here's the activation function given below. The accepted convention is y equal to 1 if sigma and I equal to 0, wi into xi, which is less than or equal to 0. That is equal to 0 if sigma n I equal to 0, wi into xi greater than 0, where x not equal to 1 and w not equal to minus theta. Let's talk about some. A vector can be defined in more than one way. For a physicist, a vector is anything that sits anywhere in space, has a magnitude and a direction. For a computer techie like us, a vector is just a data structure used to store some data, that is integers, strings, etc., that we write on programs. Here, in order to generalize to higher dimensions and to relate vectors to the ideas of pattern space, it is convenient to describe vectors with respect to a Cartesian coordinate system. That is, we gave the projected lengths of the vector onto two perpendicular axes. This is the figure. And the vector is now described by the pair of numbers v1 and v2. These numbers are its components in the chosen coordinate system. Since they completely determine the vector, we may think of the vector itself as a pair of component values and write v equal to v1, v2. The vector is now an ordered list of numbers. This definition immediately generalized to more than two dimensions. An n-dimensional vector is simply an ordered list of n numbers, v equal to v1, v2 up to vn, the weight vector w equal to w1, w2 up to wn, and the input vector x equal to x1, x2, xn are depicted similarly. Vw equal to v1, w1 plus v2, w2. Angle between two vectors formula is given here. Weight in perceptron. Yeah, this is what we see that the weights which are used in perceptron. We can see that the perceptron creates yy, which is just the weighted sum of the inputs multiplied by an activation function in the image. It's a step function. So the weights are just scalar values that you multiple each input by before adding them and applying the nonlinear activation function, that is w1 w1 and w2 w2 in the image that is given above. So putting it all together, if we have inputs x1 x1 and x2 x2 which produce a known output yy, then a perceptron using activation function aa can be written as y dash equal to sigma a xi into wi, y dash equal to sigma a xi into wi. The values of these weights are what we get trained in the perceptron in such a way that such a way as to minimize some error metric between y and y dash.